Hi, everybody. In this video, we're going to talk about two different topics. We're going to be talking about 11.2.1, which is Introduction to Single Variable Polynomials. So single variable meaning like it's just going to have x's in it, or it's just going to have y's, or a single type of variable. And then the second topic we're going to talk about is Unit 11.3.1, which is Simplifying and Evaluating Polynomials with More Than One Term. And I want you to be careful in your EdReady module because the 11.2.1 topic is at the top. It's that top topic or that first topic in the unit of polynomials. And then the simplifying and evaluating polynomials is the last, I think it's the last one. I'm pretty sure it's the last topic in that unit of polynomials. And then you're going to have all these other topics in there about adding and subtracting polynomials and multiplying and dividing them. And we're going to cover those in the next video. But here, the introduction to polynomials and then simplifying them and evaluating them, those kind of ideas go together hand in hand. So we're putting those two topics in this one video. So just be careful when you get ready to go do your EdReady practice problems and your other homework for those topics, that you're paying attention, that you're doing the first topic, that is introduction to single variable polynomials, and then the last one, simplifying and evaluating those polynomials. All right. Here we go. So let's talk about the definition of a polynomial, first of all. So a polynomial is an expression. So there's that term expression, meaning mathematical expression versus equation. So if you don't remember, go back in your notes. A few topics ago, we talked about an equation versus an expression. And that mathematical expression can have constants, variables, and whole number exponents. So far, the first part of that definition was pretty much the definition of a mathematical expression. And then we get a little bit more specific about what a polynomial can be, and it has to have whole number exponents on those variables. So remember, what is a whole number? A whole number is zero, or it's any positive number, any positive whole number, right? So it's like your natural numbers, your counting numbers. So that means no negatives, no fractions. The constants, variables, and exponents can be combined using mathematical operations. So what does that mean a polynomial cannot have? It means it cannot have division by a variable. Because what would that actually mean? So if we have division by a variable, like something like this, well, why can't we? Well, let's rewrite it. So if we rewrite it, if I want you to bring that x up, it would be 2x to the negative 1, right? That's just using your exponent rules from a couple videos past. So the negative 1, is that a whole number? No, it's an integer because it's negative, right? Whole numbers are 0 and then counting numbers. So it's like 0, 1, 2, 3, and then it keeps going up to infinity, but it's only that 0 and the positive, your positive integers there. All right, so we can't have division by a variable. That also means you cannot have negative exponents on a variable. And these two things are really talking about the same exact situation, right? So here's negative exponents on a variable. Here was division by a variable. Another way to say division by a variable is that you can't have a variable in the denominator. So that would be another way if you want to pencil it in on your notes. Another way to say this exact phrase, division by a variable, that means that you cannot have any variables in the denominator. The last thing, we don't really see too much in this class. You can't have an infinite number of terms. And when I say you don't see it much in this class, I mean you don't see it at all. So you're not going to see an infinite number of terms for anything in this class. All right. So we've got specific types of polynomials. We've got a monomial. Use your prefixes here to help you. It's a polynomial with exactly one term. So you could have something like this, 2xy squared. That's a single term, right? Because it's xy squared. It's an xy squared term. You could have 1/5 x. You could have 1/5. You could have negative 2/3 x squared. Could have something like that. Those are all monomials. They're single terms. A binomial, use your prefix. Bi means two. It's a polynomial with exactly two terms. So maybe I'm just going to combine the ones up above. Maybe it's like 2xy squared minus 1/5 x. Maybe I've got 1/5 x plus 1/5. So those are binomials. They are exactly two terms. Trinomial, tri means three. It has exactly three terms. Guess what I'm going to do? I'm going to combine some of the ones up above. So maybe it's like 2xy squared minus 1/5 x plus 1/5. That would be a trinomial. You could even use a combination of constant terms. We could have something like negative 2/3 x squared plus 2 plus 4. So that's one term, two terms, three terms. If we combined them, if we combined 2 and 4 and we got negative 2/3 x squared plus 6, what would that be? That would be a binomial then. Okay, next question. How do we figure out the degree of a term? The degree of a term, we are going to figure that out by finding the sum of all exponents of the variables in a single term. I don't want you to confuse that with this. Degree of a term versus degree of the polynomial. So examples. Let's see. So if we look at this one, 5a squared b to the fourth. We're looking at the sum, that's the answer to an addition problem, of all the exponents of the variables. So here we go. If I'm looking at the variables, I'm doing 2 plus 4. And again, don't let this confuse you with your exponent rules from previous topics. We are not doing exponent rules right here. We are finding a degree of a monomial. So the degree of this term would be 4, 5, 6. This would be a sixth degree monomial. And again, this is just our kind of skill that we're practicing right here, is us finding out the degree of a term and then we're naming the term. And we're going to do a bunch more practice in that table that I just put an arrow on. All right, let's find another one. Let's say we had 3 squared x y to the fourth. 3 squared x y to the fourth. Don't let that 3 squared mess you up either. What are we counting? We're counting the sum of all exponents of what? The variables, not the coefficients. So we would be counting up here the 1 on the x and then the 4. So 4 plus 1 is 5. This is a fifth degree monomial. All right, so then how will that compare to a polynomial? Well, a polynomial means we're going to find the degree of each term in the polynomial, and whichever one of those terms has the highest degree, that will also be the degree of your polynomial. That's what we're going to fill in these blanks. It's going to be the same as the degree of the term with the highest degree in a polynomial. So for example, we have got, let's try this. We've got 3a cubed b minus 5a squared b to the seventh. So we are comparing the degree of this term to the degree of this term and which one has the highest degree. So 3 plus 1, that's 4. And then 2 and 7, so we're counting those, is 9. So this one is a 9th degree binomial because it's a two-termed polynomial. All right. There's your example of your finding the degree of your polynomial. All right, we are going to do a couple more practice here, finding the degree of each term. And let's try, we're just going to do a couple more. We've got -3 to the 4th, x to the 4th, y squared z. What is the degree of that term? We're not counting the -3 to the 4th because remember, we're only looking at the exponents on the variables. So we've got 4, 2, and then this implied 1. So 4, 5, 6, 7. So that's a 7th degree monomial. And then we're going to do one more because it's kind of a special case. One more. Let's try like -15. So we've got a constant term, -15. First of all, is it a polynomial? Well, just look at what it happens if it's not a polynomial. Do we have any variables in the denominator? Do we have any variables with a negative exponent? Well, let's look. No, we don't have any variables, period. So we said no to those. So is it a polynomial? Yes. Well, then what's the degree? How do we figure out the degree? If we wrote on here like this, x to the 0, what does x to the 0 equal? X to the 0 equals 1, right? So if I do -15 times 1, do I still go back -15? Yes. So I show you that because look at this. Come back here. I'm showing you that what we started with, -15, I can put this piece on here, and I'm showing you how we get all the way here, and it gets us right back to where we started. So what now is the degree on your variable? We have a variable. What's the degree on it? It's 0. So this would be considered a 0 degree monomial. So a 0 degree monomial. All right, I'm going to cross off 2 examples that I did not do so I don't forget and then ask you guys about them or say, hey, why aren't these in your notes? Well, they're not in your notes because we didn't do them. All right, well, let's fill in our table. So it says complete the table below. I'm going to give you some examples, and then I want you guys to determine whether a polynomial. If it's a polynomial, what type? Is it a monomial, binomial, trinomial, or other? Other would be 4 or more terms. If it is a polynomial, what's the degree? Then we're going to classify the polynomials by the degree and type, kind of like what I was doing right here and what I did right here. And then if it's not a polynomial, we're going to explain why it's not a polynomial. So here we go. This first one's going to be 2x to the 4th y minus 5x cubed minus 10x squared y to the 3rd. So first of all, is it a polynomial? And again, the thing that you should be looking at are the variables. Do we have any negative exponents on a variable? No. Do we have any variables in the denominator? No. Okay, so that means yes, it's a polynomial. So yes, it's a polynomial. If so, what type? Well, let's count the terms. One term, because they're going to be separated by addition or subtraction signs. 2 terms, 3 terms. So it's a trinomial. Okay, what's the degree of the polynomial? What's the degree of this first term? We've got 4 and 1, so this is a 5th degree term. What's the degree of the next one? It's a 3rd degree term. And the degree of my last term is another 5th degree term. Which one is the highest? It's 5, right? It's a 5th degree. So here we go. We're going to classify it. We're going to say it's a 5th degree. What type? Trinomial. All right, let's try another one. We are going to try 16 n to the -4th. 16 n to the -4th. Is this a polynomial? So look at the variables. Do we have any negative exponents on a variable? Yeah, we do. Do we have any exponents in the denominator on a variable? Well, not at the moment, but I can rewrite that one as 16 over n to the 4th, right? So it fails that entire category. Is this a polynomial? No. So then we have to explain why it's not. No because variables can't have negative exponents. Perfect. Let's try another one. We're going to do 3x squared plus 5/8 x. Ready, set, go. Try that one out. I'm going to write up another example. All right, how about number 3, our third line? Is it a polynomial? Yes, because look at your variables. Are there any variables in the denominator? Nope. Do we have any negative exponents on the variables? No. Therefore, yes, it's a polynomial. What type? How many terms do we have? We have 2, so it's a binomial because here's your first term. Here's your second term. If so, what's the degree? What's the degree of our first term? It's 2. What about the second one? It's 1. Which one's the higher one? Obviously 2. So it's going to be a second degree binomial. How about the next one? What do you guys think? Do we have any negative exponents on a variable? No. Is 5 a variable? No, it's a constant term. Do I have any variables in the denominator? No. So is this a polynomial? Yes, it is. I know this might be shocking, but 5 to the negative 1, remind yourself, what is 5 to the negative 1? Use your exponent rules. That's 1 over 5 to the first to make that negative 1 positive, which is 1/5. Don't let that negative mess you up. All right, how many terms? 1, 2, 3. It's a trinomial. What's the degree? We have 3 versus 2 versus, remember, it's not -1 because we could rewrite it like 1/5. Any constant has a degree of 0. Has a degree of 0. So this would be 0 down here because remember, this would be the same as 1/5. And we could write it as 1/5 x to the 0 power. So what's the highest degree? It should be 3. So it's a third degree trinomial. Let's try another one. How about the number 21? Do we have any variables in the denominator? No. Any variables with negative exponents? No. Use the example we just did right here. Let's fill in an x, and it would have to be x to the 0, right? Is this a polynomial? Yep. How many terms? It's a monomial. What's the degree? It's 0. So it's going to be a 0 degree monomial. We are going to try this next one, and it says x to the 4th plus 1 all over x. I'm going to write up the examples, and then I want you guys to pause the video, and I want you to try to do these next 3 all on your own, and then I will show you, I'll work them out as well, but I want you to try them on your own. The next one is going to be xy over 3 plus x minus 3. And then the last one is going to be a to the 7th plus 2a to the 5th, b cubed minus 3a to the 3rd plus 5. So pause the video, and I want you to see how you do. All right, this first one, is it a polynomial? Do we have any x's in the denominator? Yeah, we got one right there. Is this a polynomial? No. No, because variables can't be in denominator. Boom. Let's go to the next one. xy over 3 plus x minus 3. Do we have any variables in the denominator? Nope. Do we have any variables with negative exponents? Nope. Is this polynomial? Yes. Some of you might be going, wait, how can we rewrite that? What about that 3? You can rewrite it like this too, right? 1/3 xy plus x minus 3. That works too. All right, how many terms do we have? We've got 1, 2, 3. So it's a trinomial. What's the degree? Well, here on this one, we've got x to the first and y to the first. So that's a second degree term. Here's just x to the first. So that's a first degree term. And -3, that's a 0 degree term. So our highest degree is 2. So it's going to be a second degree trinomial. And then for our last one, let's check out this last one. Do we have any variables in the denominator? Nope. Any variables with negative exponents? Nope. Is it a polynomial? Yes. How many terms? 1, 2, 3, 4. So we don't have a term, a definition or anything like that for something with 4 or more terms. So we just call it an other. So we're going to classify it as an O, an other. What's the degree? Here's 7. Here's 8, because we're taking 5 and 3. Here's a third. And here's not X. I don't know why I wrote X. And here's a 0. So here's my 8. So it's going to be an 8th. So we just say an 8th degree other polynomial. And that is it. I hope you did well on that part. So now we jump into the evaluating portion. So all of this page was essentially the introduction to single variable polynomials. And on the back, we're really doing this topic, the simplifying polynomials with more than one term. So let's go check that out. So here we are going to evaluate -3x cubed minus 2x squared when, and we've got 3 parts. X equals -2, when x equals 3, and when x equals -1. So let's do that. In EdReady, it gives you like a table for this. It'll give you a table and it'll give you the expression up here, and then you're supposed to just evaluate it and then kind of put in your answers here. So here we go. We're going to do -3 times -2 cubed minus 2 times -2 squared. So then my first step here, it's going to be -2 cubed and -2 squared. So I'm going to get -3 times -8 minus 2 times a +4. Then here I get a negative times a negative, which is going to give me a +24 minus 8, which is going to give me a 16 for my answer. The next one is going to be x equals 3. So let's plug that in. -3 times 3 cubed minus 2 times 3 squared. All right, so I'm going to do this part first, this 3 cubed and 3 squared. So that's going to equal -3. 3 times 3 is 9. 9 times 3 is 27. Minus 2 times 9. 27 times a -3 should give you -81. -2 times a 9 should give you a -18. And then if you're taking a -81 minus 18, we should end up getting a -99 for that one. All right, let's try the last one. And you're welcome on any of these. You can just pause and see how you do on these. It'd be good practice for you to try these out on your own. So we've got -3 times the -1 cubed minus 2 times the -1 squared. I'm going to do this part first, this -1 cubed and this -1 squared. -1 cubed, that's -1 times -1 times -1. That's going to give us a -1. So we're going to have -3 times the -1. -1 raised to an even power is going to give me a +1. So be careful with your negatives here. Negative times a negative is going to give me a positive. So that gives me +3. Negative times the positive gives me a negative. So I get 3 minus 2, which is going to give me 1. And there's your answer. All right, let's try more examples. This time we're going to have more than one type of variable. So this one was a single variable polynomial. And now we're going to do some examples where there's more than one type of variable. So our first one is going to have a couple parts like what our last one had. We've got evaluate for x squared y minus 2xy squared plus x minus 7. And it's going to be when, the first one is going to be when when part A, we've got x equals 3 and y equals -1. So you should try that. Your answer should be -46. So try that one out. And then part B down here, let me see how much space I have. Part B down here is going to be when x equals -1 and y equals -2. And the answer for that one should be -8. So pause the video, and then we're going to do another example over here where it's number 2, and it's the same directions. It's evaluate 2x cubed minus xy squared plus 6. And it's when x equals -2 and y equals 5. And the answer to that one should be 40. And then our last example for this page is going to be when x equals -4 and y equals -3. And the answer to that one should be -86. -86. All right, pause the video. I want you to try those 4 problems out, see how you do, and then come back and watch it if you need to in order to check your work or to see if you did something wrong in there. All right, so we've got 4 times 3 squared times a -1 minus 2 times 3 times a -1 squared plus 3 minus 7. All right, let's just go from left to right. So I'm going to take 3 squared first, and then I'm going to do -1 squared. So I'm going to have 4 times 9 times -1 minus 2 times 3 times a +1, because -1 squared is going to be a +1, plus 3 minus 7. If you want, you can go ahead and do that. Plus 3 minus 7 is just going to give us -4. All right, now I'm going to do my multiplication. 4 times 9 is 36. 36 times -1 is -36. -2 times a 3 times a 1, that's going to give me -6 minus 4. And then here I go. I'm going to do my associative property here because I'm thinking about how I want to take those two and subtract those first because they're going to give me 10. So I'm going to do -36 minus 10, which gives me exactly what we were hoping for, which was the correct answer, -46. Let's try the next one. So we've got 4 times -1 quantity squared times a -2 minus 2 times a -1 times a -2 squared plus 3, right? Minus 7. Am I getting that right? Yes. No, it is supposed to be an x. Sorry. was looking at the previous problem. So it's going to be plus, I got to look at my expression. There we go. So minus 2 times the negative 1 times the negative 2 quantity squared plus, let me get back to my black marker, plus a negative 1 minus 7. All right, here we go. So I'm going to do this squared part. I'm going to do this squared part. Are they actually both squared? They are. All right. So it's going to be 4 times a positive 1 times a negative 2 minus 2 times the negative 1 times a positive 4. Here, this is the same as minus 1 minus 7. So that's going to give me negative 8. Now I'm going to do this part and this part. 4 times 1 is 4. 4 times negative 2 is negative 8. Here I've got a negative and a negative, which means I know I'm going to get a positive. So then I go 2 times 1 is 2. 2 times 4 is 8. And then negative 8. Well, this is kind of cool. These things cancel out. And I'm left with negative 8, which is, guess what? The correct answer. Throw confetti in the air. It's always a good day when you get the right answer. All right. Let's try this one. So we've got 2 times negative 2 quantity cubed minus a negative 2 times a 5 squared plus 6. All right, I'm going to do this negative 2 cubed and 5 squared first. So I'm going to do 2 times a negative 8 minus a negative 2 times 25 plus 6. Here, this is going to be negative 16. My minus a negative is going to give me another positive. 2 times 25 is 50 plus 6. So if I'm thinking about negative 16 and positive 6, that's going to be negative 10 plus 50, which gives me 40. And that's your answer. All right, let's try our very last one on this page. And it is going to be 2 times negative 4 quantity cubed minus a negative 4 times negative 3, quantity squared plus 6. All right, so then we're going to take this negative 4 cubed. So negative 4 cubed should give me a negative 64. Then I'm going to do this negative 3 squared. So I'm going to have minus a negative 4 times a positive 9 plus 6. Then 2 times a negative 64 should give me negative 128. And then I'm going to do my negative times a negative here is going to give me a positive. And then I'm going to get 4 times 9, which is 36 plus 6. And then honestly, just going across and adding or subtracting, we should end up with our answer here of negative 128 plus 36 plus a 6, because that's negative 128 plus 42. That's going to end up giving us a negative 86. And we are done. So that's it for this video. Thanks everybody for tuning in.